Let us refresh slot and filler structure in artificial intelligence. We have been to this topic before in the previous module. This is actually used in the field of knowledge representation. It enables attribute values to be retrieved quickly. We can store attributes in the form of fillers. The values will be considered as fillers, and those can be accessed quickly by indexing them in certain order. So the statements are indexed by the entities, and the binary predicates, the predicates which are used with two arguments are called as binary predicates, are indexed by first argument. Suppose this is an example if team within bracket Neeraj, India. This is a binary predicate because the team is having two arguments, Neeraj who is belonging to India or Indian team. So for faster retrieval, these such entities will be, or objects will be arranged or indexed based on the first argument or first statement. And the properties of relations are easy to describe by the use of the slots and filler structure, because the attributes and their values are mapped in a table format. So we can easily describe the properties of relation between objects. It allows ease of considerations as it holds features of object-oriented programming. So the data is given importance in these type of representations. So a slot is an attribute value pair in its simplest form. A filler is a value that a slot can take. So there should be a slot to hold a value. This value is called as the filler of that slot. And this value can be of any type. It can be numeric, alphabetic, float value, string. Any value is permitted to hold in the slot. And then we have two types of slot and fillers. One is weak slot and filler structure, and the other is strong slot and filler structure. So far we have seen only the weak slot and filler structure, and the type of weak slot and filler structures are semantic net and its enhancement, which is the frames. The knowledge in slot and filler system consists of structures as a set of entities and their attributes. We have seen that the structures and their attributes are described in this slot and filler form, and the attributes will be mapped with their valid values. The structure is called as weak slot and filler structure. A weak slot and filler structure does not consider the content of the representation, and it is having two types, that is semantic nets and frames. On the other hand, strong slot and filler structure represent links between objects according to more rigid rules. So this is also a mapping between attributes and values, but they will be mapped according to some complicated rules. So we will have some more accuracy in the representation of the values, or we can go to the value system in a more specific manner than the generic forms. So in summary, we can say that slot and filler structures can be divided into two, as weak slot and filler structure and strong slot and filler structure. And weak slot is again divided as semantic nets and frames, and the strong slot and filler structure are divided into conceptual dependency and scripts. We will be moving on to this topic very soon, and we are familiar with the weak slot and filler structure, that is semantic nets and frames. Those attributes will be considered as slots, and its value will be considered as filler. Now let us see the weak slot filler structure. As we have said, semantic network forms one form of weak slot. It represents knowledge and supports reasoning. So this form of representation, knowledge representation, is familiar in or popular in artificial intelligence because of its use in natural language processing and as it supports reasoning. They are widely used in knowledge representation. These act as another alternative for predicate logic. We can easily convert the values represented in predicate logic into its corresponding semantic net form. Semantic net consists of nodes, links, and these links are labeled. We will be forming a graph or tree with nodes and directed links or edges, and these edges are given some label based on the relation between those nodes. So this forms a semantic network. For example, say Jill and Jack are two nodes and they are connected with the relation that Jill is the sister of Jack and Jack is having another attribute that it has only one leg. Jack is a member of male person, Jill is a member of female person. In turn, female persons and male persons are subset of persons, the entity persons. Again, persons can be a subset or instance of mammal, and person is having two legs. These are all attributes, and these nodes are connected with some relation with other nodes, and these relations are marked with directed arrows or edges, and they are labeled with the kind of relation that they hold between them. So this is the representation of semantic network. Then we have seen frames, another form of knowledge representation. A frame is an extension of semantic network. We have also done exercise on this too as to how semantic figure in semantic network can be converted into its corresponding frame notation. When we see the representation of frame, we can easily say that it looks like a semantic net. Suppose I will read it out for you because it is not clear. The writings are not clear. This is a university. It has two succeeding nodes as department and other one is hostel, and they have the relation like department is a part of university, so as hostel is a part of university. Then we have faculty, which is a part of department. Then Nilgiri hostel is a hostel. Then science faculty is a kind of faculty, and Renuka is a science faculty. So if we look at this figure as a whole, we can say that it is a representation of semantic network, but each of these nodes can be expanded or it can hold some other value, some more values in a table like form or in a record like form. In other words, it can have different fields having different values. So this is an example of that. Here we have one frame which is having the name of university and the departments it has. Likewise, it is having some more information as compared with that of a node in semantic network. So we can connect several frames in this manner with some kind of relation, and each of the frame will be having a different fields as its values. We have also seen the association between frame and semantic net. As I have said, frame is an extension to semantic net. Anything that is represented on a semantic network can be easily converted into its corresponding frame format. And we get two types of frames. One is the declarative frame and another one is the procedural frame. Declarative frame will be having only the declaration about the status of or the values that they hold in that node, whereas procedural type of frames will be describing the actions that are performed in each of the node. One video which supports this statement is being provided for you after this session. Then frames are primary data structures used in artificial intelligence frame language. So here again, as we have seen in semantic network, which is used with natural language processing, frames are also used with natural language processing. So for that, we can use these frames as a primary data structure for structuring or processing the sentences in a language. Frames are also an extensive part of knowledge, representation, and reasoning schemes. So in whatever form we use semantic net, that form can also be used in frames also. So for reasoning purpose and natural language processing, we can use frames. Then we will have the strong slot filler structure, which is scripts, and other form is conceptual dependency, and we will discuss that in the next class.